anyone try downloading the ChemDraw? Tell me in the chat what the success rate was. So it looks like several people said yes, 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 and got it. And some people say no. Did you download the ChemDraw and were you able to open it? Have you tried that? I mean, because downloading is one thing, but actually opening up the application is quite another thing. So what happened there? You were able to download it. Were you able to open it up? Opening was good, got it to open. So you have the ChemDraw window, some of you? Yes, you got it to open and you have a window there. So I see a lot of yeses. So yes, no, it's not an application. All right. Chem office professional, I guess. Don't really know what the version is, but I think maybe that would be the right one. Well, if you don't, if you can't open it up, if you can't download it and open it up right now, that doesn't really matter because we'll just spend some time talking about uh, the lab in general, and I'll also talk about using ChemDraw and the Avogadro. All right. So it's the lab, and you know, there's a it's kind of weird trying to have a lab with no lab. It's like trying to play basketball with no ball and no hoop, or hockey with no ice. But somehow we'll try to muddle along and provide some kind of experience that where we do many things that one would do in the lab without actually having to get our hands dirty. Okay, so let me just make some general comments about the laboratory. Okay, so the philosophy of the lab is that of guided inquiry. And so what you're going to be doing in the lab is that you're going to be, and not every lab is going to be the same. You'll see this first lab is going to be quite different from something that you might think of as a chemistry lab. But what you're going to be doing in the lab will be analyzing data, right? So I'll just give you the data that maybe you would have collected in a laboratory and ask you to tell me stuff about it. This could be stuff like the percent yield, the purity of the sample. When we get into spectroscopy, you'll be analyzing the spectra. So just be giving you data that you might have collected and be asked to analyze it. You will also be watching and evaluating videos, right, that I'll be posting on the course website. And some of these videos will be videos that I just downloaded from YouTube or from the Royal Society of Chemistry or something like that. And these are going to show someone performing laboratory operations. And some of the other experiments will be a real human being will be carrying out the experiment, and you are to watch the video and evaluate the video, and I'll ask you questions about the video that I would like for you to answer. As far as remember, the labs are Mondays and Thursday. Monday and Thursday, I believe the lab begins at 11:30. And not all of them will go for the 3 hours that are budgeted. This is supposed to go to 2:30, I believe. Not all of them will go to the full 3 hours, but some of them might. And the first lab is Monday, the 1st of June. And then the last lab, I'll write all this down in a lab syllabus. The last lab will be Thursday, the 18th of June. So we'll have 6 lab experiences. That's what I'm hoping for. And then there is a multiple choice lab quiz during the lab lecture time. And this will be a multiple choice quiz of maybe 20 or 25 questions or something like that. And this will be the 23rd of June. Okay, so that's the plan for the lab. Okay. Now, as far as what documents that I'm expecting you to hand in, so let's say to be submitted, and this is all going to be through that grade scope thing, to be submitted. And so here you will have the lab write-ups or the lab reports. And the lab reports are essentially fill in the blank. I'll show you what one looks like in a second, but it essentially will be fill in the blank lab reports, where I ask you to address an issue, and then you will respond, right? And then ask you to address another issue that was brought up in the course of the lab, and you will respond to that in writing. Okay, and the lab reports, their structure is there's a section called pre-lab questions. And so this is just something that I would like for you to fill out before. I mean, this is like something that should fill out and hand in with the lab report. I call it pre-lab because ideally you'll be writing this up before you do the lab experience, just as a sort of introduction, so that you know what's going on and you know what to be looking for. It's not to be submitted early or anything like that. But a lab report is a one package deal, one multi-page document, but there is a section in there called pre-lab questions. Ideally, you want to answer these before the lab experience so that you know what's going on. And then there is what we could call the post-lab questions. And this is, more fill in the blank where I'm asking you to comment or to analyze or to write a paragraph or to do a calculation or something like that based on the lab experience that you just had. And the role of the teaching fellows, the role of the lab supervisors will be to guide you through the various the various aspects of the guided inquiry. All right, so let me show you what one of these lab reports will look like. I'm going to post these on the course website, but haven't done that yet. So let's see. On my share here. Let's go over here to Blackboard. Okay, come on. All right, so maybe something like this. So this isn't our course now, but this is what we're going to go for. I'll be posting these in plenty of time for you to download and read through and all of this other stuff. So maybe something like this: synthesis of Doulson. Okay, so see, these would be the pre-lab questions. See, it's fill in the blank, and I'm asking you a question and asking you to respond. And then there will be these are the lab report form. This is the data sheet. And some of the experiments have simulated data, which I'll be asking you to analyze. So that's simulated data. And then these are the post-lab questions, which are, more fill in the blank stuff. Here I'm asking you, how many moles of a certain substance did you use? And here I'm expecting you to write up a calculation or present a calculation. And what was the percent yield and so on. And then when we get into spectroscopy, and so this is, another question. So here, answer space, discuss the purity of the sample that was created in the video, and I'm asking you to respond to it. And so here is a spectrum. When we get into spectroscopy, this would be a piece of experimental evidence, experimental data that you would collect, and I would ask you questions about what exactly you're looking at and what the meaning of this data is. So that's what the lab report. That's what the lab report is going to look like. Okay, so any questions so far about anything? So just to recap, is that our first lab is next Monday. And we have 6 labs, Monday and Thursday, Monday, Thursday, Monday, Thursday, 6 labs. And then we have a lab quiz on the 23rd of June during the lab lecture time. And the documents that you'll submit are these essentially fill in the blank stuff that I'll be posting on the course website. Okay, so here's a question. What are the due dates of the post-lab? Okay, so the Monday labs will be due on Thursday, and the Thursday labs will be due on Monday. That's what I'm thinking of right now. If we need to make the deadlines a little bit more lenient, we will. But that's what I'm thinking. The Monday lab will be due on Thursday, and the Thursday labs will be due on Monday. Anything else? Any other questions about anything? Okay. So, since we have to do everything online, I thought that something that we might do as our first lab experience, but which is something that ordinarily we wouldn't do at all, is to really use the computer to do some of the stuff that organic chemists do on a computer. So first thing would be getting familiar with how to draw chemical structures using a computer, right? You can always draw it by hand, but the pictures are prettier, and it's frequently, although not more efficient, it's frequently just a better presentation if you can draw structures on the computer. So that's why I am asking you to download and become familiar with the ChemDraw. All right, so let's spend some time talking about ChemDraw. So if you haven't been able to download this, well, this is not, nothing's an emergency right now, but let's just see about this ChemDraw program. All right, so this is what, so let's see, let me get rid of this window. All right, so here's the ChemDraw window. I opened up ChemDraw, and so let's just go through some of the basics about how to use this program and how it's going to impinge on this first lab that we're doing. Sharing is paused. Okay, so let me try again. Okay, so maybe now that's better. Yeah, sorry about that. Okay, so here's so I opened up ChemDraw, and this is the ChemDraw window. So let's just go through how we draw structures. Can you see me now? Can you see this now? Yes. Okay, all right, thank you. Because I don't know what you can see and what you can't see. Sorry about that. Okay, so here you have up here, the most important thing is these floating palettes, right? So you have a view up here in view, show main toolbar, hide main toolbar, show main toolbar. And so these are the tools, these are the various tools that you use to draw structures. Okay, so let's say I want to draw a molecule. So here's my solid. Click on that. This is my bond, and I can make this a double bond by clicking it. All right, so this is how you draw a bond here. Then if you make a mistake, this is your eraser, right? You can erase. If you want to draw a triple bond, so this button on the toolbar, triple bonds, so you're clicking on that, and so here's a double bond. Here's one of those things that we would use to draw a partial bond in a resonance structure. Here's a triple bond, and all this other stuff, I don't think we're going to be using it too much. So let's say if I wanted to draw an alkyne, so I clicked on the triple bond, And so there's my carbon-carbon triple bond. Okay, so now this A over here, this is how we add letters that symbolize the different elements. So I click on this and then move over to where I want to draw the atom. And so I see that little blue dot that has appeared there. So I click on that and I get this box where I'm supposed to enter text. So maybe I would put an N there, right? And maybe on the other side here, I still have my element selected here. Go over here, put a C, right? And so there I've made the nitrile functionality, and now see how this carbon has this red square around it. That means it's missing bonds because carbon forms 4 bonds. So let's put a single bond in there, looking like that. And over here, maybe I want to write a CH3 group. So back over here to my arrow, to my alphabet letter and my blue dot. And now maybe I want to write CH3. All right, and the ChemDraw will justify and adjust the graphic in such a way. See, it wrote it here, CH3. Let's say I don't want H3C. Let's say I want CH3 just for looks. Okay, and so how can I make this CH3 rather than H3C? Well, that's up here. So this is left justified. This is centered, right justified. So now I would type CH3. I don't want ChemDraw to fix it. I don't want ChemDraw to make it H3C. I want it to go in as CH3. So write CH3 and then click right justified. See, so it didn't fix it. So once again, there's my triple bond, alphabet N, alphabet C. Draw the 4th bond to carbon and write CH3 here. And now ChemDraw sometimes fixes these structures. Okay. All right. Question. We can't really see the top of your screen. What did you click to not make it change to CH3? Okay, so what I clicked was, yeah, I have all of this Zoom stuff. Can I move this down? Oh, good. Yeah. Great. All right. So what I clicked, okay, so let's do that. Let's do that again. So erase on this eraser. I'm going to erase that. All right. So there's my bond. There's my alphabet. And I want CH3, and I don't want ChemDraw to fix it to read H3C. This is just for looks. And so I would go up here to the right, justified. Right, so did that answer that? Okay, so I'm clicking this, here I have left justified, centered, and right justified, centered, and justified, and so on and so forth. Okay, so when you're drawing so someone is asking, how did I get the subscript? Well, ChemDraw does that automatically sometimes. See, I'm writing CH3, 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 CH2, CH3. That's a condensed formula. All right, and now, so that's in my alphabet here. And now click away. Oh, it didn't do any subscripts or superscripts. Okay, but sometimes it will do it automatically and sometimes it won't. So now I want to make this 3 a subscript. I want to make this 2 a subscript. I want to make this 3 a subscript. So I highlight the text, and up here I see, oh, this is formula. and I click this CH2 up here, and it subscripts whatever it thinks should be a subscript. Okay, I could also maybe subscript the whole thing. See how tiny that got? Or maybe I could superscript the whole thing. See how tiny that got as well? So up here, this is how you superscript and subscript individual letters that ChemDraw doesn't fix for you. But in a structure, when you're drawing a bond line structure, it will usually put in the subscripts and the superscripts for you. But if it doesn't, you have to go back in and fiddle around with this toolbar up here. Okay, so how about let's look at this toolbar a little bit more and see what else we would need. This lasso here, this is the selection tool. So you select it, and now you've selected all of that, and I can do various things here. I can just get rid of everything that I selected. Whoops, that didn't work. I can get rid of everything I selected on the keyboard. I would see maybe up here, edit menu, delete. See, deleted everything that was selected. Let's bring it all back. I can do other things. I can do other things like maybe if I want to increase the size, right up here I have a menu, I have a font menu and a font size. So everything is selected. Let's see that again. All right, there's my selection tool, selected that. Now I want to increase everything to 24, 24 point. Don't change settings. See, it increased everything. So that's a selection tool. Okay, and so this is structure perspective. I don't think we need to use that. This is how we draw bonds. That's the erasure, multiple bonds. This is how we add letters. This is how we add letters. And you know, one of the other things that we want to use is the whole convention of dashing and wedging, right? When we're trying to illustrate the 3D structure of a molecule. So what I'm going to do is, see, I'm drawing a bond line structure. That little blue dot means it's going to create those bonds. And let's say I want to show dashing and wedging here. So I selected the wedge tool. Here it is. Select the wedge tool, and I wedge it down like that. And now I want to select the dash tool. There it is. There are two different dash tools here. And so something like this. And now maybe over here, I want to put OH. Whoops. I want to put OH. And maybe over here, I want to put CH3. And then maybe here, I want to put a hydrogen, right? So I have my alphabet tool selected, and I'm just clicking on where I want the text box to appear, and maybe put BR there. So there I've made a dash and wedge. So we use this dashing and wedging quite a bit. There are two different styles of dashing and wedging. Okay, so other important stuff that maybe you will need to use quite frequently is that sometimes, you know, unless you are pretty experienced in this, you know, the whole point of using ChemDraw is that you are able to come up with some beautiful structures, right? You're able to come up with some beautiful structures that maybe are not, maybe will look better than something that you just draw by hand. I would encourage you to use this, especially when you're doing lab reports. So, you know, whoa, that was wrong. So maybe something like this. Okay, see, so this has gotten really ugly, right? Really ugly. So another feature of ChemDraw that you can use is that up here, object. No, select this object, then go up here to object and go up here to structure, and you see clean up structure. So when you click this, ChemDraw is going to take this kind of ugly drawing and try to make it look pretty. So let's see what happens here. Structure, clean up structure. All right. So let's look at the before and after picture. That's before, and I'm going to try to clean this up, clean up structure. Well, it looks a little bit better. Let's mash down, clean up structure again, and let's see what happens. Okay, see, well, now that looks very pretty, right? Mash down, clean up structure again. And okay, so now it's just diddling around, not really doing anything too significant. So that's another thing, another tool that you can use that I think, well, I use that quite frequently, you know, like I want to draw a 6-membered ring, but maybe I don't have that much experience or that much coordination. And so like I'm drawing something that looks really ugly. I'm drawing something that looks really ugly like that. And now hit clean up. The structure is selected. Hit clean up structure, and it'll take, well, okay, so finally on the second try, it came up with a nice hexagon. So that's the before picture, that's the after picture. So this is another thing that you can use to clean up the structures, make it look a little bit nicer. All right, so lots of times I can't see the toolbar. You can't see this? Right, you have a toolbar up here and you have another toolbar here. So can you see the toolbar now? Oh, so much stuff in these windows. So how we doing? Sheeran can't see the toolbar. The top one is the problem. Okay, this one, maybe something like that. Is that better? Okay, so let's look at some other things. Some other things here that we use frequently is chemical symbols, the charges. So I click on this and hold, and I see this is how I could draw a positive or a negative, right? So for example, something like if I wanted to write something that has an O minus, I can do this in a couple of different ways. I can draw my bond line, then click my alphabet, O, and just a negative sign. See, it will superscript it like that. That would be one way of drawing a negative sign. Another way would be, let's just put an O there. And you go over here to the chemical symbols. There's my negative charge. This is going to be a lot prettier. And you bring that negative charge up to the oxygen. It's just a little bit more, just a little prettier. Okay, so I'm going to get rid of all of this and I have to finish up. So this is something, if you're able to download and open, you want to play around with it. Other stuff that you can do here, let's see, we have this thing that looks like a rubber stamp. A rubber stamp's a real old-fashioned thing. So let's see, let me select all and get rid of everything. All right, so this rubber stamp, this has all kinds of different options here. So you want to play around with this. So something that you do that we probably the most useful thing here, not right now, but a useful thing would be maybe something like the bicyclics. Right, so this is how you can draw some of these complicated complicated molecules. So just play around with this. You can do it all manually, but this is just time saving. Okay, and so we talk a lot about rings in organic chemistry. So here are the rings. You have 3-membered ring, 4-membered ring, 5-membered ring, benzene ring down here. We're not into the chair yet, but here's the little template. You can make a chair. We'll be talking about this in the lecture later. Okay, so that is ChemDraw. So, this is something that I would encourage you to use on a quiz. You probably don't have time unless you're really fast. Probably don't have time to play around with ChemDraw. Maybe just draw the structures manually. But in other contexts, for the lab reports or for other applications, this is pretty nice. Okay, so I'm going to leave ChemDraw and I'm encouraging you to play around with this. The stamp function, there's a section for the functional groups. There is functional groups. So for example, see, you can do all this manually with bonds and the alphabet tool, but this is just time saving. So here I want to draw an ester. There I want to draw an ester. So I went to rubber stamp, functional groups. That's what an ester looks like. So I selected it. And so there's the skeleton of the ester, but maybe the ester I want to look at actually has maybe a benzene ring here, and maybe it has a 6-membered ring over there. So this is just a time-saving thing. Okay, so I need to get out of this now and go on to something else. So any questions? So please play around with this. Any questions about the ChemDraw? Okay, so exiting file. Do I want to save the file? Yeah, save. Right, and so I can just save and save it for editing later. Okay, so quit. Delete. I don't want to save any of that. So the first lab experience is going to be about molecular modeling, where we're going to be using this Avogadro program. So what was the success rate in downloading Avogadro? Can you tell me on the chat? So people got it, were able to open it. Okay, great. Okay, so let's open up Avogadro. So this is, since we have to do everything on a computer, I thought, well, let's do stuff on a computer. All right, so this is molecular modeling. And so this requires quite a bit of playing around. There is a manual online, so I would encourage you to read that. But let's just go through some of the basic stuff that you're going to be doing at the first experiment. Okay, so in first experiment. So this is the window. This is the window. And so let's see, how do we draw a molecule here? Okay, so the draw settings, right? This pencil here, this is how we edit. This is how we edit. Oh dear. It's supposed to be sharing, right? Share. Avogadro. Sorry about that. Okay, so you can see I'm sharing this window now. Okay, so this is the Avogadro window. This is the molecular modeler. So see this pencil here? This is how we edit, how we draw a molecule using this Avogadro. And so in this draw settings, this is saying it's ready to draw a carbon atom. And the 6, that's simply the atomic number of carbon. So I'm going into this black window over here. I can change the background color. I don't want to do that right now. And I just click. And so this has drawn a model of a carbon atom with the appropriate number of hydrogens. See this adjust hydrogen button here. Okay, so now let's see. display settings, display settings. So here we have all kinds of different models. So that's a stick model, but maybe I want ball and stick. See, so this makes ball and sticks. Or maybe I want the van der Waals sphere. So this is a space filling model. Okay, so this display settings, this is giving you the various different models that you can use. Some are better than others. I much prefer this ball and stick to anything else. Okay, so let's get rid of this display settings. And now, how would we draw another bond to this carbon atom? So I have carbon selected here. Bond order is single. I'm going to adjust the hydrogens. I'm going to go into this black area. And there's my carbon atom. And now I'm going to drag until that line merges. And so that I've drawn a carbon-carbon single bond, or I could make a carbon-carbon double bond as well. So go into this black area, click somewhere, there's your carbon atom. And now this is, see, there's the double bond growing until it merges with the other one. And there I've drawn a double bond. Okay, and so now maybe I want to draw a triple bond. So there's my new carbon atom. There's the triple bond, drag until it merges, and there's the triple bond. Okay, so this is how we would draw a carbon-carbon bond. Let's try to draw something that's not carbon. So we go up here to element. Let's change one of these hydrogens to a fluorine. So I'm selecting fluorine. I want to draw a single bond. You have to tell Avogadro how to do everything. And now maybe this hydrogen, I want to make this a fluorine. So I'm going to click on that. And so that's just changed it to fluorine and with a different color. So now maybe I want to make that a bromine atom. So I'm going to click on that. That makes a bromine atom. And just for fun, if we go to van der Waals, we see, oh, bromine is huge, right? Whoa, that's wrong. What do I do? That's wrong. Okay, so let me see. Let me get rid of this. All right. Okay, so now let's talk about something that's a little bit more advanced than just drawing molecules. What about manipulating the structure? All right, so I'm going to draw this molecule here. What happened? Try again. Okay, so now let's manipulate this. So you see this hand here, right? Now my hand is selected and I'm clicking on this black area here and I'm rotating the model around in space, right? So this hand here, right? So this is how you can manipulate the model in this window so that you have different vantage points. Okay, and so this arrow here, this is the selection tool. Let's say I want to get rid of this carbon. So I selected this arrow. I mean, I selected that carbon, and now I'm going to hit delete. Could also do it from this menu bar over here. Just delete it. See, but it just deleted the carbon. It didn't delete the hydrogens. So maybe selection tool is selected, select. I'm holding down the shift key and maybe cut. So that got rid of that. Okay. So get rid of that. All right. So so this hand. This is how you manipulate the model around. All right, the selection tool. So now let's do something that's a little bit even more advanced. And let's see, I want to go to this pencil. This is how I edit a molecule. So I want a carbon there. I want another carbon here. And I want maybe a double bond here. I hope that works. What happened? Try again. Okay, is that a double bond? It is, right? So they're manipulating that. And now maybe I want to draw a single bond. Oops, that's wrong. Sorry, guys. All right, I want to draw a single bond to carbon, maybe something like that. Okay. So obviously, this is very, very far from what this molecule would really look like, right? Because this is sp2 hybridized carbon. This is just a very unrealistic model. So just like in ChemDraw, you have cleanup. Here you also have a kind of cleanup. Okay, so this is what your first lab is going to be mostly about. It's going to be minimizing the energy of these molecules. So, so I have all this, I have this step-by-step in the write-up, so don't think that you have to memorize all of this as we're going through it. I just want you to see what the possibilities are. So you go up here to extensions, optimize geometry. Oh, but you know what? I want ball and stick. All right, so see how ugly that is and how unrealistic that is? So I just drew this kind of freehand, but now I want to clean it up. Extensions, optimize geometry. Oh, okay, and so now back here with my hand, so that's all very nice, and it's been, so I have the proper bond angles here, and so on and so forth. So this is how we can clean up the structures. You can draw something that looks really ugly, but then we can clean it up. Okay, another thing that we're going to be doing in this first lab experience is we're going to be using the Avogadro to calculate the energy of the molecule. Okay, so I drew it, that freehand drawing, I cleaned it up. See how it's still moving, so mash this a couple of times, it's still finding. Okay, so it stopped moving, so that's the optimized geometry. So you go up here to extensions, molecular mechanics, calculate energy. Oh, okay, and so it gave you an energy here. But this number has to be used with caution, because what it is giving you is the energy of the molecule that is frozen in this conformation. So this would be the energy of this molecule if the molecule were frozen in this shape. But in a real sample, the molecule isn't frozen like this, because as we'll see in the lecture, I guess starting tomorrow, how single bonds rotate. So we can also show the rotation of these single bonds using this Avogadro. So let's go through that. Okay, so go up here to this 90. This is called the bond-centric manipulation tool. And I'm going to click on that. And then I'm going to click on the bond that I want to rotate. All right, and so what it's doing here, it's telling me what the bond length is, and it's telling me all about the different angles here. And I want to rotate this bond. So what I do now is click this hydrogen here. See how that blue turned into yellow. And now now I can rotate around this bond. And this is what the molecule is actually doing. It's not frozen in that shape, in that conformation that Avogadro is giving you. This bond is rotating, as we'll see in the lecture. Starting tomorrow, this bond is rotating at a very, very high rate at room temperature. Okay, so now let's see. So I want to get rid of this. Oh! All right, I don't know what happened. Try again. Okay. My Zoom. Where is my Zoom? There's my Zoom. Share my screen. Let's try again. Okay, so I don't like that model. I like ball and stick. I like ball and stick. Okay, and so now what I'm going to do is I want to view this molecule edge on. Right, let's optimize the geometry. Optimize the geometry and look at this molecule edge on. You see how these hydrogens are pretty far away from each other, but this bond is rotating. So I can go up here to the bond-centric manipulation tool, click on the bond I want to rotate, and then click on the atom that I want to rotate. Click on the atom that I want to rotate and rotate this like this. And now if I look at this molecule from a different perspective, you see how I've eclipsed those hydrogens. And this is going to be a higher energy than before. Okay, so you see how those hydrogens are right at each other's faces. When I go to the van der Waals sphere, I see how these hydrogens are pretty close together. All right, and so now let's calculate see, with those hydrogens eclipsing each other, let's calculate the energy. Extensions, molecular mechanics, calculate energy, minus 7.7, okay? All right, and so now what I'm going to do is I'm going to de-eclipse them. Bond-centric tool, rotate that bond so those hydrogens aren't that close together anymore. What did I do? Change my perspective. You see how those hydrogens are now farther away. Click on extensions, molecular mechanics, calculate energy. Remember what number we got before? It was -7. Now it's -18. So what Avogadro is allowing you to do is to calculate the energy of the molecule as it adopts different shapes. And so that's one of the things that you're going to be doing in your first lab experience. Okay, so there's another level of cleanup, which is up here, extensions, molecular mechanics, conformer search. So this is finding the lowest energy shape, the lowest energy conformation for the molecule. So let's click on that, conformer shape, just click OK. All of this is all preset. You really can't mess around with that. Just click OK and watch this model, see what it does. See how it changed a little bit. Let's do that again. Molecular mechanics, conformer search. Click OK. Is it going to move again? No, it didn't move again. So this is here it has found the lowest energy conformation. So let's go up here to extensions, molecular mechanics, calculate energy. Remember, we got a -7 and then we got a -18. This is now the lowest energy conformation. What is it giving us? -19. See, the energy came down a little bit because what Avogadro has done is found the lowest energy conformation. So, I have all of this in the write-up, so don't feel you have to memorize all of this clicking around because there's a lot going on in this program, and it's it can be buggy and hard to play around with. But I have a step-by-step for all of this. For now, what you're just doing is getting familiar with the interface and playing around with the molecule. Okay, so now let me show you one more. Let me show you one more thing, is that sometimes you have to draw a very complicated molecule. You can get the ChemDraw and the Avogadro can work together. Okay, so I'm going to quit Avogadro for now. Don't save. Yeah, I'm going to go back to my ChemDraw window. ChemDraw. All right, so why isn't ChemDraw coming up? Okay, here's my ChemDraw window. All right, and so now what I'm going to do is I'm just going to draw a big, god-awful, complicated molecule, okay? Boom, boom. Maybe put a 5-membered ring here. Maybe put a benzene ring over here. Maybe a dash Cl over here. I hope I'm not getting too cute. Maybe put a dash Cl there, and maybe a wedge hydrogen there, a wedge hydrogen there, and a wedge hydrogen over here, maybe something like that. Right, so this would take a very long time for me to draw in that Avogadro. So let me show you how ChemDraw and Avogadro can work together. Okay, so what I'm going to do is I drew this complicated molecule. I'm going to select this molecule, go up here to Edit, Copy as Smiles. So this is just computer code, copy as Smiles. All right, and so now let's go back to Avogadro. So that structure has been copied as Smiles. Okay, and so build, insert, Smiles. Okay, so paste what is in the buffer into that Smiles fragment, right? So this is just all a bunch of computer junk here. Okay. Oh. And so it has taken that ChemDraw picture, select none. It has taken that ChemDraw picture and it has translated it into something that Avogadro can understand. So there's my benzene ring. There's my 5-membered ring over here. There are my 6-membered rings. How about let's optimize the geometry. So see, it's really, maybe do that again, optimize the geometry. Okay, there's no more motion over there. And so this is just a shortcut that you can use to, when you need to copy or you want to look at a model of something that's pretty complicated. Okay, so that's all the time we have today. Just wanted to introduce the ChemDraw and this Avogadro. And so I'll be posting the document for the first lab experience on the course website. And so, in plenty of time, I'll have that up today and you can start reading that and getting familiar with the with these molecular modelers. And what we're going to be talking about in the lecture is going to also help to help you with this lab experience, what exactly you're looking at and what exactly you're investigating. Okay, so that's all the time we have for today. Is there any questions before we break? There is no lab textbook, nothing to buy. Whatever you need, I'll just put it on the course website. Anything else? Okay, so watch the course website, and I'll be posting the document for the first lab. Okay. All right. See you tomorrow.